Hello people, welcome back to my channel. So in the last video we saw the very first or the primitive type of classifier method, that is we had the holdout method. So in today's video let's see the repeated iteration of this holdout method in order to improve the classifier performance, that is we have the random subsampling technique. So this method is a very simple method and it's based on the holdout method which you've seen in the previous video. So what you have is you have a random holdout method iteratively applied over every step, and then you just evaluate the error, and after that you just estimate the accuracy of that particular model. So let's consider this example. So what basically happens is that you have this data set. So just consider 10 instances are there in this, and this is the very first iteration. So what you have is basically in each of this data set, every portion which you can see. So here I have considered two different colors for numbering this. So you have blue color, so this represents the training data, and whatever you see in red color, that is a test data. Now you have this data set is divided into n number of training as well as test sets. So here in this data set you have this portion as training data as well as this portion as training data, whereas these two records which you can see, these are the test data. Now in iteration 2, that is the second iteration, you have this same samples, but I just considered that is the 23rd sample as for the training data, and I just considered the 24th sample as the test data, and then I had the rest of the portion similar in this way. Then for the third iteration I have these many samples, that is I have considered the very first this much record in the same way, and then I have considered the 28th sample which was there previously in the test data. Now I have considered in the training data. So this majorly overcomes the problem of having the data in both the training as well as test set. So this was one limitation that we have seen in the holdout method. So that is mainly solved in this approach. Now first question is that how many iterations do we have to take? So that is dependent upon the analyst. So that is estimated with the help of a factor called as k. So k is determined till that k. So for k is an integer, so if it is 5 or if it is 3, so you can just iterate that many times, and after each of this you just train the model with the training data set, and then you just evaluate on the test set, and so you will get some error. So this is error 1, and with this you get some other error, that is error 2, and you get the third error for error 3. So in this I have just considered k is equal to 3, and so I have just taken these many data sets, and I have just randomly divided into a number of training and test sets. So this division, as you can see, I have not considered any particular general rule or any algorithm for this. So it's just a random. So it's upon the data analyst discretion, like how he wants to divide the test set or the training set. He can do in that way. So there is no particular rule or something like the generalized golden rule for dividing the training and test set. So it's completely based on the random approach. Now what you do is you just estimate the accuracy of the entire iteration or the entire sets which you have divided into training and test set with the help of this formula. Now this is just a mathematical equation. So ACCI represents the accuracy at the very ith iteration. So here you have accuracy at the third level. So this is simply E1 plus E2 plus E3 divided by 3. So whatever error you obtain here, that is divided by here, and you get the average of this. So that value becomes the accuracy of the subsampling. So this is represented as the accuracy of the subsampling technique. Now there is one limitation in this approach. So that limitation is that so you can see this portion, that is this record, you can see this is 28th and 29th record. So you can see the similar which you can see in iteration 2 as well. So this is what you can see is a overlapping of the test set. So there is a problem of test set overlapping problem. So that is the main disadvantage of this approach, means you don't have any control over how many times your training and test data will be used in the further iteration. So that is unknown to the user. So that is the main disadvantage of this. So in order to overcome this, we have some other methods postulated that we call as a cross validation, and k-fold cross validation also give the nested cross validation. So that we'll see in the subsequent videos. So well, that was all regarding the random subsampling techniques. So hope you guys enjoyed this video. If you got educated watching this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.